Lesson 4. Center of Mass. In our final lesson, we will locate the center of mass for various systems. For particles on a straight line, you find the center of mass by multiplying each mass by its position, adding those products together, and dividing by the total mass. This exact same formula works in 2 dimensions using position vectors. For uniform 2-dimensional shapes, known as laminas, the center of mass is located at the geometric center. A uniform circular disk's center of mass is exactly in its middle by symmetry, and a uniform rectangle center of mass is at its geometric center. For a uniform triangular lamina, the center of mass sits at the centroid, which you can calculate by simply averaging the coordinates of its 3 vertices. When dealing with composite bodies, like 2 uniform rods joined end to end, treat each part as a single particle located at its own center of mass. A 1-meter rod has its center of mass at 0.5 meters. You can then use the standard formula to find the overall center of mass for the combined shape. Finally, you must know how objects behave when suspended freely. If a uniform lamina, like a square, is suspended from one vertex and hangs in equilibrium, its center of mass will always rest vertically below the point of suspension. Because the center of mass of a square is on its diagonal, suspending it from a corner means that specific diagonal will hang perfectly vertical, making a 0-degree angle with the vertical axis.